Hi everyone and welcome to this special edition of New Breakpoint for Microsoft Ignite 2021. My name is Simon Waite and I'll be your host for today's show. Before we start, I would like to acknowledge the Gadigal people of the Eora Nation as the traditional owners of the country on which I'm presenting from today. We recognise their continuing connection to the land, waters and community. We pay our respects to them and their culture and to elders both past and present. I also acknowledge that we have a number of people presenting from around Australia and around the world, in fact, joining us today. I would like to acknowledge the traditional owners and custodians of those lands and pay my respects to elders past, present and emerging. All right, so what do we have on today's show? Well, first of all, we're going to have a look at quantum at Microsoft. We're joined by Dr. Chris Granade and Professor David Reilly, who are going to run us through what's happening in the world of quantum hardware and quantum software design at Microsoft. We'll then be joined by Lisa Crosbie and Amey Holden, two Australian MVPs who are going to talk about how to next level your career. We'll hear their journeys and how they've next leveled their careers and give you some tips on how you can next level yours. If you'd like to join in, you can use the chat box on the Microsoft Ignite website. So that's if you're watching this live. If you are catching the show later on catch up, you can always tweet us on our Microsoft AU Dev Twitter handle or leave comments on our playlist on the Microsoft Australia YouTube channel. Please keep in mind that we do ask that you collaborate with other people in the community in a safe and appropriate manner. So please take time to read our code of conduct and make sure you understand it. All right, that's it for the introduction. Let's get started. First up, I'd like to bring on David Reilly, Professor David Reilly, who is a partner researcher and director of Microsoft Station Q, Sydney. He's a chief investigator in the ARC Centre of Excellence Engineered Quantum Systems and a professor in the School of Physics at the University of Sydney. Welcome, David.
Hey, nice to be here.
And I'm also happy that we're also joined today by Dr. Chris Granade, who is a software development engineer working in the Quantum Systems Group at Microsoft. Chris is actually an honorary Australian, having done their postdoc at the University of Sydney. Welcome, Chris, and thanks for joining us today.
Thanks for having me here.
All right, so without further ado, I think everyone who's watching can probably guess we're here to talk about everything quantum. We've got a couple of experts in the room. So what I'm going to do is I'm going to open up the floor and I'm going to ask Professor Reilly, tough question, explain to the audience what quantum computing is in 10 seconds.
Well, very good question. 10 seconds, I'm down to 8, 7, 6. Quantum computing, quantum mechanics is wave mechanics. We're talking about the interference of waves in order to process information. Those waves are actually nanoscale objects like electrons or fundamental particles, or the fundamental particles of light. I need more than 10 seconds to tell you about why matter and light should interfere in that way, but this is wave mechanics, wave computing, but using the wave nature of reality to do things that you can't do with a classical computer for certain types of problems. It's
that space that I think is very interesting to people, that idea that we have this new way of computing, or this new potential way of computing. Having had the visit to the centre here at the University of Sydney, I think it felt to me very much like probably what the dawn of modern computing felt like, those early stages of research. Now, Microsoft's been doing research in this space for a while. We have locations all over the globe that are contributing towards our efforts, and we're working in conjunction with universities like the University of Sydney. We're doing some different research though. Having read a little bit, we're kind of focusing on a thing called a topological qubit versus the other qubits that some of our competitors in the market are looking at. I guess the question for you, Professor Reilly, is, the research that we're doing being different to a lot of the others in the industry. Are we like that crazy meme guy with all of the string on the wall over the pictures? Maybe we're off in a different space, or are we like that? But are we John Nash in A Beautiful Mind, where potentially we're gonna have that insight in that moment? Where are we and how do we fit in? What do you think on that one?
Simon, it depends on what the end goal is. If what you're trying to do is build a machine that is going to go and do something that's impactful to people that aren't nerds, that don't really care about the underlying physics, but care about what this machine will do. When is it going to solve, a problem in quantum chemistry that may impact their lives? if you think along those lines and think about building a machine that is going to be sufficiently scaled up and powerful that it can go after those hard problems, and if that's the goal, in other words, not just build a quantum computer, but build a quantum computer that's useful, even if you don't know what a quantum computer is. If that's the goal, then we have to be able to actually create a machine whose underlying constituents, that is qubits, its building blocks, have certain kinds of attributes that make them scale, make them such that you can really build a large and powerful machine. So you mentioned kind of the competition. There's a lot of different flavors of qubits at the moment, these building blocks of quantum computers. Those flavors of qubits map onto different underlying physical systems. Some qubits are built from electrons or properties of electrons. Some are built from properties of photons, and so on. And we haven't yet, as a community, realized the ideal qubit, the one that's going to have the attributes that would allow it to scale to a machine that's sufficiently large that now you can go and really, tackle hard problems. Microsoft has spent a long time understanding what are the attributes of qubits that you need in order to build a powerful machine. And our goal is to build a machine that's going to do something useful. So we are searching in some ways and trying to engineer qubits that have properties and attributes for scale, as opposed to, building a machine or building a kind of toy that is a really cool, interesting physics experiment. I personally love that as a physicist. That's super interesting. There's new science there. That's a great endeavor.
Yep.
But if you really want to build a machine at scale, we've got to actually go back to the starting line and try and get this qubit technology where it needs to be, the kind of properties in order to scale. And one of those properties is actually something that relates to how a qubit reacts to noise. Qubits being, they obviously represent quantum information, which is extremely fragile. Qubits are sensitive to noise in a way that classical bits are not. Digital representation of a classical bit is insensitive to noise. Here we are with a very, it's an analog system, a system that wants to interact with its environment and its world on a microscopic scale. Those noisy systems, in order to encode information and process information with them, we need systems that somehow are protected from their environment and those noise sources. And that's what we're trying to build. Within Microsoft, we're trying to engineer what's called a topological qubit. That's a qubit that uses properties of topology in order to encode information in a way that makes it insensitive to first order, to noise and interactions with the environment. A qubit that has these properties that it's insensitive to noise allows it to scale, build a machine big enough that you can tackle real world problems. So that is a differentiator. We are definitely, focused on the really long-term effort here about what it's going to take to build that real machine, as opposed to more near-term, exciting and interesting, developments, but not really the type of technology that will take us all the way.
Okay. It sounds like maybe we're a bit more in that John Nash corner than the crazy meme guy corner, which is fantastic. Professor Reilly, the work that your group is doing is focused very much on the sort of the hardware engineering side of things. But Microsoft is also doing a lot at the higher level to help build abstractions and languages to help people actually program quantum computers, which is a new thing, right? So having spent a little bit of time digging through Q#, it feels a bit to me like an F# style functional language, but it has aspects of procedurals, things like C# built into it. Chris, I guess the opening question for 10 points for you is, what do you need to learn? If you're a developer in a classical computer sense, or maybe you're learning about development, what are you going to need to become a quantum developer?
Well, I think the thing I always come back to is that, quantum computing on the whole is pretty challenging, just in terms of how many different backgrounds you really need on a team to realize, the things we've just heard about. But where that's a real opportunity is it means whatever background you have, there's a challenge that needs exactly that background to go meet. So I think there isn't really one right set of skills to get involved to start making an impact on quantum computing. I think there are certainly some skills which tend to be useful. So like having some linear algebra really helps. But, it's the same sort of linear algebra that you might use in computer graphics or machine learning, and so even there, like, there's a lot of good resources to get started with and to get up and running, and a lot of diagnostic tools built into the quantum development kit and Q# that can help you learn as you go. And I mean, to that extent, something that I found really transformative, moving from kind of thinking in terms of research to thinking in terms of software development, is when I run a Q# program and it doesn't work. I see it doesn't work. I get the wrong answer when I run it on a simulator. And that gives me the feedback I need to go re-examine, oh, hey, where did I go make a mistake, and go fix it. Whereas, I'm used to thinking about trying to debug a page of math. And that's a lot harder because you can't even run that and see, oh, hey, I got the wrong answer. Let me go revise that. There's something really transformative about having something concrete that I can run on a simulator and get those diagnostics out and use that to build my understanding as I go. Yeah, I think there's a lot of opportunities to bring what you care about, what your passions are, to have an impact on. And there's a lot of good resources to learn as you do so.
Professor Reilly, will we have, applications that can utilize quantum computers in our lifetimes?
Hard question to answer. To connect with what Chris said, at the moment, the community broadly is still grappling with what is this technology good for? And it's hard to answer that question without having some of the hardware already in place. I mean, it's a little bit like trying to write and debug computer code on paper, as Chris mentioned. I remember being, I think 11 years old, 12 years old, and I didn't have a computer, and I asked my parents for one, and they said maybe. And in the meanwhile, I tried to write code on paper. And I collected all these pieces of paper. I finally actually ended up with a Commodore 64. I copied all of my handwritten, code, and none of it worked.
Yeah.
And it's pretty hard to not just debug, but even develop a concept of how to think about these types of technologies unless you have access to them. Mm-hmm. So, there's a relationship here between the hardware and the software world where we're grappling with what is it good for, hard to do ahead of time. And, classical, the sort of development of classical computers from the transistor and vacuum tubes through, as I think really taught us that it is very hard to see into the future and anticipate what may come from technology until you can unleash it, until we can put quantum technology into the hands of people worldwide and let them do with it whatever they want. That's when I think the new applications come. So, of course, from a mathematical point of view, there are certain algorithms you can analyze, and you can see that there is an advantage. If you're able to switch on quantum mechanics, then there is a certain power that comes with that for certain types of problems, and you can talk about which algorithms are more efficient than others and so on. But I think that it won't just be the mathematical optimization or efficiencies that drive the technology. It may be along a different axis. It might not be the question of does a quantum computer outperform a classical computer for a certain task, meaning the amount of resources, the number of clock cycles, the effective memory, and so on. It may be something totally different. It may not be that underlying mathematical optimization, but actually turns out the way of thinking about this problem maps very well into that hardware. And yes, you could map it into regular classical machine, but that mapping is complicated, and that limits what you can imagine doing with the technology. So we're at an early stage. This is why we need people to engage with this field, to learn how to think about quantum mechanics, to learn how to think about how to program such a machine, because I think that's where the new applications are going to come. And we definitely can point to examples already where we know this technology is powerful, but it's those ones that we have yet to anticipate, I think, that are, almost by definition are going to be the most interesting and exciting, the ones we haven't anticipated.
Okay, fantastic. And Chris, where do you see this going? Where do you see it having benefit and impact?
And I think there's a lot of ways in which putting the right tools out there in the hands of people passionate to solve hard problems, that they care about, that impact them on a daily basis, that's where we're going to find new solutions to that. And so we're seeing a lot of, focus from our team and putting out the quantum development kit and putting out Q# And now, as you say, spinning up the Azure Quantum service, putting that into public preview, we put things out there like libraries to help you explore and understand how all of this impacts chemistry and machine learning and numerics. And as that kind of grows, it's exploring new problem spaces and trying to put tools, in your hands so that you can go explore and find those, either deeper applications that we already know about, or to David's point, the surprising ones that we haven't even thought of yet. And it's that exploration that I think is really promising, exciting, and it's what I really love seeing users do with the QDK and Q#.
Professor Reilly and Dr. Granade, I want to thank you very much for joining us today. Give everyone a wave out there in viewerland. Come on, David, there we are. Thank you very much. All right, thanks a lot for joining us for this part of our show for Ignite today. We'll be back in a few moments. Thanks a lot, everybody.
Thanks, Simon.
Thank you.
Welcome back, everybody. Now I'm joined by two of our amazing Australian MVP community. I'm joined by Amey. Give everyone a wave, Amey, and Lisa. And the two of them are going to have a chat about next leveling your career and going through certification and those sorts of things. So welcome, Amey. Welcome, Lisa. Hopefully you have fun. Over to you.
Thanks,
Thank
Simon.
you so much. Hello, Lisa.
Hello, Amey. We should introduce ourselves to everyone watching. This is a little bit of a chat about certifications and how they've helped us along the way. So, do you want to go first?
Absolutely. So, I think the main thing for me is my tagline, as you might see down here. I'm anything but code. My background is in kind of business and IT. I dropped into it because I didn't know what else to do, and it felt like an acceptable thing for my parents to see me do at university. Then I joined a sufficiently acceptable place to work and found out there's more to Microsoft than spreadsheets. I'm still not a developer. I refuse to do that, but I'll do anything else along the way. How about you?
Well, here's my confession. My name is Lisa, and I'm a qualified librarian. I know, shock. I actually I qualified as a librarian. I spent my first career actually working predominantly in book publishing, and now I'm doing this. So I'm actually a midlife career changer, and have been doing this for about 5 years. Also not a developer. I did a year of computer science back a long time ago, hated it, and now find myself drawing on those skills a lot. But I'm not a developer, but I do write apps and I do create awesome things with this platform. So super exciting.
It sounds like a really good, what do we call that? A midlife career crisis?
Midlife, yeah, perhaps a little bit of a crisis, but with a good outcome.
Yeah.
So,
Nice.
for anyone, we're going to talk about certification and self-education and things here. And essentially that's what I've done. You can actually, you don't have to be straight out of uni or straight, young person to do this. You can actually make a shift. And I know a lot of people have probably been forced to do that in the last little while, but I did it by choice, and I'm only 5 years in. So you can actually, there's a lot of potential here to get started. So
yeah. So you got certified.
I got
What's
certified. I did my first certification about 3.5 years ago. I think it was the first exam I'd done for, I don't really want to count how many years since I'd previously done an exam. I was so nervous. And the first one I did, it was prompted by my employer saying, hey, go do this. But the first one I did, the self-satisfaction of knowing that I was at that level. So especially if you're new into this, I think one of the first things can be that personal satisfaction of achieving that and knowing that you can learn that stuff and apply it. From there, it becomes, for me, it's become a way of structured study and staying up to date with things. I've done a lot of demos recently with the marketing app, and so I went back in and did that certification so that I knew that I was credibly up to date with everything. And as I'm talking to people, I've got all that information under my belt. So, I still like the little badges and things, but really it's about making sure you've got the right information and that you're working with the right information.
It's more than just a badge.
But I do like the badge.
Yeah, I fully agree. I find that stamp of approval from Microsoft, because it's like, yeah, my employer knows I'm great, but then I've just been recognized by someone else as well. So it's pretty good for the ego and the confidence as well. And I found that really helpful. Like if I'm on a customer site and they ask those curly questions, for want of a better term, and for some reason I know the answer, I have no idea why. And apparently it's because it was on that exam I did 3 years ago.
And I know you've done this as well, but venturing into exams that are outside of your core territory as well. So you've done a bit of that too, right? So, you and I both work primarily with Power Platform and Dynamics 365. I ventured into doing some Microsoft 365 certifications and AI certifications, foundation level. And, some of that seems at the time, oh, why would I do this? And then the very next day, that breadth of knowledge where it comes up and it's useful to you. But I wouldn't have sat and done that had I not had that incentive to do an exam. But it helped me make me better at my job from having invested that time.
Yeah, it was always those things that are kind of on the edge, because like in the Power Platform, you can't ignore the fact that Microsoft 365 exists and Azure exists. But I used to like quiver a bit inside every time someone mentioned Azure, and I'd be like looking for the nearest developer. So taking on the fundamentals course meant that I could say Azure Service Bus with reasonable confidence that there wasn't a man driving a bus down the road.
I spent a day of my life learning about security and all of those kinds of things. And I can say that's not my next career path for sure, but knowing it is relevant to everything we do. And so, there's a path of certification to build up in your area, but also to build breadth across other things that I think make you a more valuable consultant or employee, whatever it is you want to do, because that breadth of knowledge is really helpful.
I think as well, the last thing that makes me want to do it sounds terrible. The certification belongs to me. It's not like, yeah, great, I'm good at my job and I got this special company special award. But if I walk away from that job, it kind of doesn't mean much. Like, well done at your job, but carry on. Whereas these belong to me. And usually the employers pay for it, or there's loads of deals and offers on at the minute to push them out. And they belong to you. And they go on your LinkedIn profile, you get your pretty badge, and you're living the dream.
Exactly. Yeah. So they point to your employer for the duration of that employment, and certainly it helps your employer to have that, but it is yours. And you win both ways. So what about barriers and things? Like, why do people not do this? What are the challenges? Yeah. Why wouldn't you?
We make it sound so fun and cruisy, right? We're like, this is the best. Yeah. It's not.
You have to do the work. So I think time and energy is a big one, right? Like I'm studying for these in my personal time, often on a weekend, or I'm sitting them early in the morning. Like it's the knowledge you develop if you're working in the space certainly helps towards it, but you still have to sit down and do the study or the revision, and it does take that commitment for most of us, I think, of personal time.
Definitely. I think for me, the way I persuade myself to do anything, I like to think of future Amey.
Yes.
Future Amey will be grateful. And sometimes I know I've said this and future Amey hasn't been grateful, but in this circumstance, she's really grateful every time. And I find that really helps. And once you've done one and the future Amey from then becomes current Amey and she's grateful, I can then think about future Amey again and she will be grateful every time.
I think that's, future self is a good one. For me, there is the just book it in and do it, right? So I do hear a lot of people going, I don't have time, when this project's over, when this thing's over. It's not like anything in life, right? There's never going to be a perfect time for that. I just pick a date in the calendar that is not too far in advance, because if it's 4 months in advance, I will start prepping 2 days before that date. Yeah. I'll put it a couple of weeks out and put it at a time where I think, there's a morning that I can manage or whatever. And then usually it's just that weekend or the day before I'm like, oh, right, that's there. That's there. I better do that. Honestly, every exam I've ever done is seriously just because I put it in the calendar and committed to doing it. There's nothing more magic than that, really.
I think as well as getting it in your calendar, telling someone or many people that you're going to do it.
Broadcasting it. Saying I've signed up for this exam, and then you committed, right?
Yeah. And then people are going to come back to you and be like, oh, how's that exam going? And you can be like, oh, yeah, still not booked it. And they're checking in on you without you asking them to, which I think really helps kick you forwards.
I would also say for me, the having to do it online was a little bit of a barrier. I was a big in-person person. And so make sure you have a proper trial practice run of that and give yourself enough time in the setup the first time you do that, because that can be a barrier for some people as well. Now that we've talked about how awesome this is, what should people do?
Yes. So I think my first one's already come out, which is, I think you've said you book it in, and I've said tell everyone you're going to do it. Mm-hmm. So I think that's 2 big call to actions. And I think my other one would be go and do an exam, fail it, have a little cry, learn some stuff, feel better about yourself when you pass it the second time.
Yeah.
Like failure isn't a reason to not do it. The fear of failure.
I've heard the thing about doing an exam as a way to prep for an exam. You know, failing is a way to pass the next time for sure. I'd also make sure people know about Microsoft Learn. You can actually create collections in there. You can sign up and get a learning path. And if you're like me and you like the badges, you'll get little progress badges and things as you go along, but really good guiding learning paths, all completely free. So make sure you go there. There's cloud skills challenges as well that you can sign up for. So, you know, lots of ways to kind of do it as part of a group or something like that if you want to do that and share that stuff.
And do it for yourself. Like, it's yours at the end of the day. You walk away, it belongs to you. You've got your medal, your badge, whatever you want. Like, take it.
Even if your employer is paying for it. If you're working for someone who's offering to pay for it, do it. Take that opportunity, right?
All very great and useful points. I think the other thing to bear in mind is Microsoft at the moment is doing free exams attached to certain learning paths. So sometimes people are a bit put off about the idea of having to pay for an exam that they then might not actually pass, but you're actually spot on. The best way even I find to prepare for an exam is to sit an exam. So if you can get a test exam, great. If you can do the actual exam, you can do it for free or for low cost, and we often do that, and that's a great way as well. Look, fantastic discussion. I think watching the two of you, you could probably talk for a long period of time on this. It's an interesting space. I think, like a lot of things, there's never been a better time to get out and do this. You know, both Microsoft locally in Australia and globally, and the industry as a whole is increasingly becoming accessible for a lot of people to learn about new topics. So I want to take this opportunity to thank you, Amey, and Lisa for joining us on this special edition. You can find Amey and Lisa's details, their Twitter handles, in their display badges on this stream. Like most of our wider MVP community, they're always open to feedback and looking to see ways that they can support and help you. So thanks a lot for joining us today, Amey and Lisa.
Pleasure. Thanks for the badges.
Pleasure.
So there we are. What a great episode that was for Microsoft Ignite March 2021. I hope you've really enjoyed the show. Check out the link that's on the screen at the moment if you want to find out more about the shows that we run and when the next one's on, and how to get in contact with us. My name's Simon Waite. I hope you've enjoyed this episode of New Breakpoint. I'll see you next time.